Okay, yes, sir. And second MCQ is what is the approximate a percentage of oxygen in the Earth atmosphere today?
What is approximate?
Do you know this is the exact value of oxygen present in the Earth atmosphere?
I think it couldn't be 100%. There's no way.
Actually,
80%, I don't think so.
actually, the percentage of oxygen in the Earth atmosphere is 21%, but it is near around about 20%. Okay. So
Oh, okay.
if we see the concentration of carbon dioxide in the Earth atmosphere, that percentage is 0.03%.
So it would be 20%.
Yeah, 0.3% present carbon dioxide and 20% present oxygen. Okay.
Okay,
And
yeah.
78% is present nitrogen oxygen. And this value are given in the table of your book. Okay.
Okay.
Okay. So next MCQ, which two of the following increase the percentage of oxygen in the Earth atmosphere?
Um, it's not active volcanoes. I think it's algae and plants evolved and
Okay. Actually,
um
two things are present in our Earth, like algae and plants.
yeah.
Photosynthesis process is taking place in algae and plants. When you know photosynthesis is the process in which carbon dioxide and water combine and they release oxygen as a byproduct. Do you know the equation of photosynthesis?
I remember it.
Like
It's,
6
it's
carbon dioxide react with 12 water of molecules. And in this way, one glucose molecule is produced. That formula is C6H12
O6 and then plus
O6. This is
plus
the formula of
6
glucose that is synthesized in the photosynthesis process, and they release oxygen
6
6 molecules as a byproduct.
O2.
So this
Yeah,
oxygen
O2.
molecule cannot be utilized by photosynthetic plants like algae and plants. This oxygen is released in the atmosphere. So this oxygen is accumulated after when this goes into the atmosphere, animal breathe in for their respiration process. Okay?
Okay, yeah. Yeah, I get it. Yeah.
So option will be algae and
Algae and
plants and
plants and
photosynthesis took place.
photosynthesis.
Two answers
Yeah.
are given.
Yeah.
Okay.
Okay.
So our next MCQs.
Let me read it.
Some scientists think that 1100 million years ago, the Earth atmosphere contains 16% oxygen and 4% carbon dioxide. And this is the figure complete y-axis. This is the y-axis where oxygen and carbon dioxide concentration are represented. And this is the percentage of oxygen in the Earth atmosphere. So according to this, we shall solve the MCQs like oxygen is produced when manganese dioxide is added to the hydrogen peroxide, then water and oxygen release. This is the experimental reaction. A student investigated the effect of changing the temperature on the decomposition of hydrogen peroxide. Hydrogen peroxide is a molecule, and that formula is hydrogen peroxide H2O2. Its formula is H2O2. So hydrogen peroxide can release this oxygen when hydrogen molecule is decomposed. So for doing this experiment, add 5 centimeter cube of hydrogen peroxide solution to 3 test tubes A, B, and C. Then you have to place each test tube in a water bath at a different temperature and add 0.2 gram of manganese dioxide. When you add manganese dioxide in this hydrogen peroxide, it splits, it breaks into water and oxygen. So this is a equation for this. But our MCQs according to this situation is which test tube contain hydrogen peroxide solution at the highest temperature? According to this.
A, because it has the most hydrogen peroxide bubble, no, magnesium dioxide bubbles.
Which will, you can see
A.
in the figure, oxygen molecule are present in test tube A.
Yeah, I said A, yeah.
So on which stage, on which concept we can say a test tube has contain hydrogen peroxide solution at higher concentration, at high temperature?
A.
On which stage we can say, on which concept we can say?
On A.
Because when temperature is high, higher molecules can be split. So when you increase the temperature, hydrogen peroxide splits very quickly.
Yeah.
So when it splits into quickly at highest temperature, so hydrogen peroxide can produce maximum water. Because when you increase the temperature, rate of reaction increases. When you increase the temperature, hydrogen peroxide splitting, hydrogen peroxide decomposition become highest. That's why hydrogen peroxide, when oxygen molecules are present high in test tube A, it means temperature of test tube will be high. Is it clear?
Yeah. Yes, clear.
On the base of temperature, we can say highest temperature will produce high molecule of oxygen.
Are you asking me the question?
Yes.
A. It's test tube A.
Test tube A. Test tube A will have highest oxygen because temperature of test tube is high. When temperature is high, more hydrogen peroxide molecule will be decomposed. You can see in the test tube A, there are maximum oxygen molecule are present. These are appear as a drop.
Yeah.
So in test tube 2, test tube B, there are few molecules of oxygen, and test tube C, there are also few molecules. But test tube has highest molecule of oxygen. The highest molecule of oxygen represents test tube A will have highest temperature because highest temperature will produce highest oxygen of molecules from hydrogen peroxide. Okay?
Okay.
So next MCQ, the student tested the gas produced. What is used to prove that the gas is oxygen?
A glowing splint.
A glowing splint. Glowing splint, through with the help of glowing splint, we can decide, student can decide the oxygen is produced. So next MCQs. Manganese dioxide does not appear in the chemical equation for the reaction. If we see this chemical equation like this, hydrogen peroxide is splits into water and oxygen because when you add manganese dioxide, Actually, manganese dioxide is a catalyst.
Yeah.
When you use any type of catalyst in the reaction, that doesn't appear. That only increase the rate of reaction. That only lower the activation energy. But it speed up the reaction. So it never appear in the reaction. That's why magnesium dioxide may be in this equation, and it is, we can say, it is a catalyst. So we see the MCQ now.
Yeah. Magnesium
Option
dioxide is a
will be
catalyst in this reaction.
this.
The
Manganese
second one.
dioxide
Yeah.
is a catalyst in this reaction. Okay.
Yeah.
Now we see the next MCQs. This question is about glass and polymers. And glass is the amorphous solid, and polymers are polymeric solids. So this we can distinguish between glass and polymers. On this base, we can conclude any type of question. Beakers can be made from porosilicate glass or polypropylene, and these are the monomers of polymers. Table 1 shows the information about material used to make beakers. Temperature at which melting point begins in degree centigrade, and porosilicate glass 850 degrees centigrade, it melt at 850, and polypropylene it melt 160. So melting point of porosilicate glass is 850 and polymer is 160. Flammability does not burn, and polymer burns. Resistant to impact, uh, this glass shatters, and polymers is tough. It cannot resist. Cost of 100 centimeter cube beaker in the solution, glass concentration is taken 1.50 and polymer concentration is 2. So according to this table, we have to solve this question. Suggest 2 reasons why a Bunsen burner should not be used to heat a liquid in a polymer. You can write 2 possible criteria about this. Actually, if we see, the polypropylene beaker will begin to melt. In the table, it is shown.
Yeah.
So it allows the polypropylene as a it can melt at the low melting point. It is flammable, so it can be ignite or melt at low temperature. This is the possible answer of this. Okay.
Because that has a low boiling point.
And question number 2. Polypropylene beakers are more expensive than borosilicate glass beakers. Suggest 1 reason why using polypropylene beaker instead of borosilicate glass. According to the table, you can see.
Because if you have one that can melt and break quickly, like the
Easily
polypropylene
broken.
ones. Yeah.
Okay, they can be break easy.
Yeah, they can be broken easily. So
this
if
is
they
the
can be
answer.
broken easily, then it'll be expensive.
Okay, next MCQs. Which is a raw material used to make borosilicate glass? Borosilicate glass is a polymeric solid, and it is, we can say it, we put in amorphous solid. It is made up of boron trioxide. Boron trioxide are used to make such type of glass. Okay.
Okay.
Polypropylene is produced from propene, and propene is a hydrocarbon. Hydrocarbon is a molecule that contain only hydrogen and carbon. So in propene, there will be 3 carbon. 1, 2, 3. You can draw like this. Polypropene, 3 carbon. Each carbon can make 4 bond. So there is propene in. In must have 1 double bond. Okay. So carbon can form 4 bond, Two bond are made already. You will put here two hydrogen to complete its four bond. And this carbon is added with three bond, 1, 2, 3. It needs only one hydrogen. And this carbon has made only one bond. It required three more hydrogen to complete its four bond. Okay. So this is the structure of propene. This is the monomer for the making of polypropene. Is it clear? Okay, according to this table, we have to solve this MCQs.
Carbon, that would be
Table 2
3.
shows some information about the elements in molecule of propene. Symbol for element carbon, hydrogen. Name of element will be number of atom of element in molecule of propene. How many carbon are present? 1,
3.
2, 3. Okay. How many hydrogen are present?
6.
3, 4, 5, 6. So if formula is not given, and you have to write that formula according to the four bond of hydrogen like I made here. Okay. MCQs number 2.5. Which structure is the repeating unit of polypropene?
The second one, because it has CH3. There's
This
only
is
one
the
CH3.
this will be the because this is the propene 1, 2, 3. Okay.
Yeah.
Because when it arranged with another molecule, then this double bond vanished. Only one bond is required because this bond is shifted to the other with other molecules. And likewise, when this polymer is used, you can say if this molecule, if we say a double bond, when it needs to connect with other molecules, then it need to end this one bond, and this bond is shifted with other molecules. Okay.
Okay.
So double bond will be ended because it need to make bond with another molecules.
Okay.
2.6 question. Polypropene is produced in three stages. Stage 1, separating large alkane molecule from crude oil, producing propene molecule from large alkane molecule when large alkane molecule is breakdown. Stage 3, joining many propene molecule together. These are all three stages in which polypropene can be made. But we have to discuss all three stages like cracking, fermentation, polymerization, reverse osmosis, and fractional distillation. We have to choose any type of process for the production of polypropene. When
It's
we
easy.
prepare propene, separating the large molecule, when you separate large molecule from crude oil, this process is called fractional distillation.
Yeah.
Is it clear?
Yeah, I know that.
It is called when
Fractional
when
distillation.
you separate it from crude molecule. This process is called fractional distillation. When stage 2, when you produce polypropene from large alkane molecule, when large alkane molecule is break down into smaller units, this process is called cracking. Cracking is done at high temperature. Cracking is the process in which larger hydromolecule are break down into smaller hydrocarbon molecule. Is it clear?
Yeah.
So stage 3, when you join smaller molecules and larger molecule is produced, this process is called polymerization. In which many smaller molecule can join and one large molecule is produced. This process called polymerization. Is it clear?
Yeah.
And some two options are given: fermentation and reverse osmosis. Fermentation is a process in which glucose or starch or other molecules is fermented into alcohol or lactic acid. And reverse osmosis is the movement of water molecule through membrane. Okay.
Okay.
Next MCQs. A molecule of hexene contain a double carbon bond. Hexene is given, it's mean there will be must double bond in. When there is given in, there will be must double bond. Many hexene molecules join together to form polyhexene. Which two words describe hexene molecule in this process? One, there is in, it will be alkene. Okay. And hexene is a molecule. When many hexene molecules join, then polyhexene is formed. The process in which smaller hexene molecule join and larger molecule is produced, that is called polymerization. And polymerization process, the repeating units are called monomer. Is it clear?
Yeah.
Question number 3. This question is about chromatography. Chromatography is a technique that is used to separate the substances. A student investigated an orange dye using paper chromatography. It is shown in figure 3 apparatus at the start of investigation. This is the beaker in which paper is placed, and this is the solvent in which this moves. This solvent is called mobile phase and paper is stationary phase. And we close with the help of lead. Then we can, according to this, we can separate different substances, different color. This is a separation technique. Chromatography is a separation technique. Following this figure, we can solve many MCQs from this. First MCQ is,
They left the investigation for too long.
we can say, you can, one thing. Okay, you have to write about this. This is the paper. This is paper. And what is this? This is the investigating substance. We can say it is a dye. It is a color because it is separating for the color technique. And this is the line through which we draw it, pencil color like, and we use in chromatography. Okay. Figure 4 shows the result at the end of investigation. The student made a mistake in the investigation. What mistake did the student make to produce result as shown in figure 4?
They left the investigation.
And this was a place where you put dye. This dye moves with the help of solvent. Solvent is called mobile phase, and this paper is stationary phase. When this color reaches from this place to this place, it means student left this process. He forgot, left the investigation for too long. Maximum time has passed. When maximum time is passed, the dye will move from this place to this place. When you given a more time, this will move from this place to this place. Is it clear?
Yeah.
So option this, left the investigation for too long. If molecules are near to this, it means we can say it was placed for a shorter time.
Tell me, what topic you're studying in your school, or if you want to study from beginning, like what you.
A different student did the investigation correctly. Figure 5 shows the result. You can see this is the solvent front, and solvent started to move from this place, and this is the dark yellow spot, and this is the pale yellow spot, and this is the red spot. How did the results in figure 5 show that the orange dye is not a pure substance? We can say there is more than one spot, and there are 3 spots, so that it is a mixture. That's why it is not pure substance. It is a mixture of 3 substances like yellow spot color, pale yellow, dark yellow, and red. What is the RF value? RF is the ratio between distance traveled by component of solute and distance traveled by solvent. You can see here, if you say this is the molecules that need to move, and you can see it is placed in a beaker. It has solvent. Solvent has mobile phase. With the help of this mobile phase, it moves here and here and here. And this is the distance of a component from original spot. You can find that distance of this component. This is called distance travel by spot. When solvent move from this place to this place, this is the distance traveled by mobile phase. This is the distance traveled by solvent. With the help of this, you can find RF values.
Also, the one dimension of economics. Okay, now, actually, to understand the economics, I will be giving
So distance moved by red spot and distance moved by solvent. Can you find this?
Okay.
And then we will moving ahead.
So
The number one,
You will
the
use your
distance-
scale to find this on the paper.
Yeah.
Do you know the name?
The distance
Have you ever
moved.
taken this name?
Would you find it? By putting the scale on this figure.
And second one is by products.
You have to find the distance of solute. You can find red spot from here to here.
Okay. So Adam Smith and Robbins.
When you need a
You will put the scale here, and that you have to count the distance of red spot. You have to put scale from here to this place. You can find the distance of pale yellow spot. You can place the scale here, and you can find the distance of dark yellow spot.
Okay.
After this, you have to find the distance of solvent from this place and tell here.
Okay. Okay.
When you find these distance, then you have to write in the answer sheet, and then you have to divide distance traveled by red spot and distance traveled by solvent. So then you will find RF value. Would you find RF value of this?
I can't find it.
Is it easy for you?
Yeah. If I found the scale, I just
Okay.
Yeah.
So which spot had the greatest RF values?
And number 4, that change.
Scroll up, sir.
You can see dark yellow spot is very, very far from its original distance, from its original spot.
Dark yellow.
So it will have highest RF value, okay?
Yeah.
The substance, the spot that is near to the original position, it will have lower RF value. the spot as very away from its original spot that will have highest RF values. Because RF value is directly proportional to the distance moved by red spot, distance moved by any spot. So answer will be the dark yellow spot. Is it clear?
Yeah.
Question number 4. This question is about a reversible reaction. Reaction in which reactants react to form products. This is called forward reaction. When products are converted back into reactants, this is called reverse reaction. Okay. So this is the reaction a student heated calcium hydroxide to produce calcium oxide and water. You have to add in this process 2 gram of calcium hydroxide in test tube. Then you have to heat the test tube and contents for 1 minute using Bunsen burner. Allow the test tube and contents to cool. Then you have to weigh the test tube and contents. Repeat step 2 to 4 5 more times. This process. According to this, we have to solve the MCQs. Reactants are calcium hydroxide. Its color is white powder. And the products, when you heat calcium hydroxide, calcium oxide and water vapors are produced. The color of calcium oxide is white powder and water vapor are colorless. The student looked at the test tube and contents during the heating. The student could not tell that a chemical reaction was taking place by looking at the test tube and contents. Give 2 reasons why use the information using the table 3.
Contribution. There should be a human labor contribution.
One reason obviously is the way of the vapor is colorless, so we can't see it. So that's one of the reasons why.
We can say, you're right, we can say water vapor is colorless. There's no color. But calcium hydroxide and calcium oxide both are colored, white powder. So there is no change in the appearance of powder solid. Okay?
Okay.
Like, should be the human labor contribution.
Question number 4.2. Accurate results are not produced if solid powder escapes from the test tube. Suggest why sealing the test tube with a stopper is not a good way of preventing the solid weight powder from escaping. So what is the answer about this? Can you guess this answer?
I would say that if it has a stopper, it might
Yes,
it might
post
create,
out a
it
slipper.
might create
Okay.
pressure. It might create pressure on heating, and then it will just like explode or break.
On other side, that is not. That is the basic definition of phenomenon.
Okay.
So it means that.
So question number 4.3. The student wanted to calculate the mass of the contents of the test tube after each minute of heating. The student weighed the test tube and contents after each minute of heating. What other measurement is also needed to calculate the mass of contents of the test tube? What will be the answer?
The mass of the. I mean,
Yes.
The mass of the empty test tube.
Mass of the empty test tube. Okay.
Yeah.
So there is a new question. The student heated 2 grams of calcium hydroxide to produce calcium oxide and water vapor. Total heating time in 0 minute mass is added as 2 grams, in 1 minute 1.76, in 2 minutes 1.64, up to so on, in 6 minutes 1.51. Choose the answer from the box. Complete the sentence.
People are having few basic needs, right?
The minimum heating time needed for all the calcium hydroxide to be changed into calcium oxide and water is. What time will be required?
5 minutes.
5 minutes. On which base you can say 5 minutes?
Because it couldn't be 6 minutes because 6 and 5 are the exact same result. So it's 5 minutes.
Okay. So in 5 minutes and 6 minutes is the same concentration.
Without that,
As given in the table.
Yeah.
Can like travel on the car.
Question number 4.5. Calculate the total mass of water produced by heating the calcium hydroxide.
That's easy.
How you will calculate?
You just subtract 2 from the 5 result 5. I don't know what result 5
You
is.
have a total
Yeah.
mass is 2 gram.
Yeah, so you minus it by 1.51.
So answer will be 0.49. Okay.
Cycle by cycle, you must have bike. If you have
The world equation for the reaction is calcium hydroxide is breakdown into calcium oxide and water. The reaction is reversible. It means calcium oxide water can be reversed into calcium hydroxide again. When 4 gram of calcium hydroxide is completely changed into calcium oxide and water, 3.03 gram of calcium oxide is produced and 5.90 kilojoule of energy is taken from the surrounding. So it's mean it is the endothermic process.
Yeah.
So 3.03 gram of calcium oxide reacts completely with water to produce 4 gram of calcium hydroxide. How much energy is transferred?
None. It's endothermic, so it stays inside. No energy.
5 point?
No energy. None. It's 5.90 kg.
Okay, this energy is given.
okay, economics is very uninteresting.
4.7. The forward reaction takes in energy from the surrounding. It's mean it is the endothermic. Heat is required. Complete the sentence. Choose the answer from the back box. The forward reaction is
Endothermic.
endothermic. Endothermic is a process in which heat is needed. Heat is added. Heat is required.
The problem of money.
Question number 5. This equation is about greenhouse gases and climate change. Which 2 gases are greenhouse gases?
Oh, that's easy. Methane from cows and other stuff, and then CO2, carbon dioxide.
Carbon dioxide and
Methane. You know the stuff that comes out of cows and stuff.
What is greenhouse gas? What is your concept about greenhouse gases?
So what do you know about bike?
Your voice is not coming.
Microeconomics deals with an individual unit.
Can you hear me? I cannot hear your voice.
Sorry. I had the mic was there's a mute button.
Okay.
I don't know why I clicked
Now
it.
you have to tell me what is
So I
greenhouse
think-
gas?
Greenhouse gas. I say it's like a gas that goes into the atmosphere. You say that, and it raises the temperature of the planet.
It increase the temperature.
Yeah.
Okay. It mean greenhouse gas is a gas. It makes layer in the atmosphere.
Okay.
When sunrise and high intensity rays is coming from the sun, and these rays reach the earth, so this layer prevent to escape out. So these rays remain in the atmosphere and near the earth. That's why temperature of the earth increasing. This process called greenhouse effect. So 2 gases are greenhouse gases, carbon dioxide and methane. Why are greenhouse gases essential for supporting life on earth?
I don't really have an answer, but I'm just gonna guess. Can I say like
Yes, because you told they increase the temperature because temperature is required here. Because
they absorb they absorb the gamma rays, right? So it doesn't hit us, right?
Yes,
like that. I'm not sure.
but their necessary or supporting life on earth is that they increase the temperature. So increased temperature and temperature is a very important factor for supporting life on earth. Okay. What is cause of greenhouse effect?
Subject here, specific concerning the
Sorry?
point. I'm just giving the overall overview so that we can have a conversation. And
Sorry, what'd you say?
Next time we can start from here while moving toward the narrow down.
I didn't hear.
And specific topic.
Greenhouse gases, they increase the temperature. When they increase the temperature, so we can say they can melt the ice. So
Yeah.
it can lead to the flood. So they can also disturb life on the earth because when it increases the temperature, some organism cannot survive in the high temperature. So greenhouse effect has many effects on the earth.
Supply side and demand side.
So it causes global warming. Okay.
Yeah.
So then you have to write only two.
Yeah.
You have to write only one because it 1 mark. Okay. Question 5.4. Which two are the potential effect of global climate change?
Demand is made by the consumer.
Higher sea level and the ice melting.
Yes.
Because when the ice melts, then it brings up the sea level.
Okay. So next question is 5.5. Water vapor is a greenhouse gas. The percentage by mass of water vapor in the Earth atmosphere is 0.25%. Calculate the mass of water vapor in 350 kg of Earth atmosphere. Give your answer in gram.
Every agent means either consumer or either producer. Every agent try to maximize its own interest.
Mass.
Try to protect your interest.
Would you convert 0.25% to 0.25 into decimal, right?
Can you solve this on your notebook?
Okay. What do you mean by that? Interest maximization or like benefit?
Wait, I can draw on it, right? Can I draw on the?
Okay, wait for 1 minute.
Exactly. Exactly. Yeah, exactly. So the consumer interest is that he must have the best
0.25.
best product.
And the
On
mass.
minimum
Would the mass be
price.
I think you divide it by 100, right?
Yes, it is 0.25%, and you have to divide 0.25 divided by 100. Okay, next.
Okay.
He must have the best product.
Then you have to multiply with 350.
But supplier want capital.
Wait, hold on. I need a calculator. I got calculator. The 0.25 times 350. 0.25 times 3.
So you can say just like that. Right?
It's 875.
Yes.
Now, look.
Okay, yes, sir. Today our class is ended. And we will continue and we'll resume this class from tomorrow. And Sir Jamshed want to talk to you.
Between both parties.
Thank you so much, Sir Mazhar. Just give me a second, Yasser. I am moving you in another room. I'm joining you. I just want to discuss with you some things.
But how this conflict will manage? Because I want different things. You want different.
Just give me a second.